Today we're going to be talking about exponential functions. For those of you who are counting, here are the standards we're going to be meeting today. In plain English, we're going to be thinking through and setting up some problems with exponential change. Now sometimes you have numbers or variables that increase by a percent. Maybe someone grumbles, oh, rent keeps going up by 5% in at my house. Maybe someone keeps saying home value has been going up for 5% each year. I've lived in this neighborhood. Exponential functions happen when you have a rate of change. That might show up as a percent change, something like double or triple, or maybe it gets cut in half. Maybe you're talking about the half-life of a molecule, for instance. Any scenario where we're talking about something becoming a fraction or a multiple of itself per unit of time is an exponential function. Exponential functions come in two forms: discrete change and continuous change. Let's talk about discrete change first, using this poor sucker whose rent goes up each year. Now, on June 1st of 2015, he signs a contract to live in a house for a year, paying a certain amount of money each month. He wants to live there again, so at the end of the year, he has to sign a new contract. On June 1st of 2016, he signs a new contract. Unfortunately for him, the homeowners have increased the rent. So if he wants to live there again, he's got to pay more money. Now, 1 year later, on June 1st of 2017, he'll sign a new contract for even more money. Each year, his rent is increased by 5%. This is called discrete change. Discrete change happens in steps or chunks, something like this. His rent goes up once per year, but for 12 months it stays the same. Then it jumps all at once. That's the important part. This formula for discrete change is P equals P0 times the quantity 1 plus R raised to the T power. P is the final population value or cost. This is normally a population formula, that's why we say P, but it works just the same with rent, it works just the same with value of homes, it works just the same with cost. Okay, so P is the final answer at a particular time. P sub 0 is the starting amount, it's the starting rent, it's the starting population, whatever your beginning amount is. R is the rate of change, so for us it would be 0.05 because that's the decimal form of 5%. And T is the amount of time that has passed. Now, we're going to talk about continuous change now. Let's compare this with the other neighbor. He says home value has been going up by 5% each year. Now, that doesn't happen all at once. You don't go to bed and then wake up and your house is worth a ton more money. That doesn't make any sense. It happens little by little. So maybe there are some big changes. Maybe you put in a pool, for example, behind your house. But more likely it's the little things. Maybe a tree got planted and it's starting to grow up and it looks very pretty. Maybe other houses that were for sale have been bought and they're no longer on the market to compete. Maybe there was a new shipping center built in town and there are new jobs, or maybe there are more attractions in town. Maybe there's a new theater or something. When change happens little by little without any gaps, that's called continuous change. Continuous change is when the number slides perfectly slowly up and down. This uses a slightly different formula. Continuous change, slides smoothly, sorry. This uses a slightly different formula. This formula is P equals P sub 0 E times to the RT power. Again, P is the final population value or cost, just like before. P sub 0 is the starting amount, just like before. R is the rate of change, just like before. And T is the amount of time that passes, just like before. The difference here is the E, and that letter E refers to Euler's number. Now, Euler is spelled Euler. Euler is a Swiss mathematician, and his number is pretty key. It's equal to about 2.71828, but you can feel free to use your calculator because Euler's number never repeats, and it goes on forever, and multiplying that by itself over and over again in your head or by hand is pretty annoying. So you can feel free to use your calculator. Here are the two functions beside each other. The top is for discrete changes, or when you make jumps, and the bottom is for continuous change, or when the value slides. In the next two videos, we'll go over an example of each so that you can solve a problem.